So our discussion for today is going to come into a new topic on empirical modeling. So everything we've done so far has been about kind of trying to find an equation that fits our data. Okay? And so a lot of times that's very good, right? Because we'd like to have something that we can use. We have some reason to believe that maybe our model is exponential or linear or logarithmic or whatever. But there are also times when we have data that doesn't really fit any of these. And we would just like to be able to say, okay, we understand what's going with this data. We don't want to try and build any kind of predictive model, but we'd like to be able to understand kind of what values we would expect on this range at least. Okay, and so this brings us to the topic of interpolation. So interpolation is the mathematical process of finding a curve, an equation, which fits exactly through our data. Okay, so everything we've done with regression has been to find an approximation, to find the curve of best fit. This is going to be a curve that fits exactly through our data. This isn't always as useful as you might think. So for example, if you have 4 points that are close to being on a line, right? Or more, let's say more than 4 points. Right? This data very clearly has a linear pattern, and so you would want to have a linear equation through it, not some kind of crazy polynomial that does this, right? That's not a very good model if we have reason to believe that there's a linear pattern. But what interpolation is going to do is it's going to give us these curves whenever we do actually want something like this, for better or for worse. Okay? So what we're going to do today, we're going to talk about first the simplest kind of interpolation, which is linear interpolation. And then we'll talk about Lagrange polynomials, splines, and some techniques for interpolating noisy data. So in this video, we're going to focus on linear interpolation. So in linear interpolation, we start off with our points, xi, yi, and what we're going to do is create a piecewise curve, piecewise linear curve through xi, yi. Okay? And so what this is going to do graphically, if we've got these points, is we're going to find the line between each pair of points, find the equation for that, and then we can use that to interpolate. So for example, if this is at 1, and this is at 2, and this is at 4, and this is at 5, this linear interpolation would let us have an idea of what's going on, for example, at 3. We could say, oh, at 3 we would expect the value to be this, right, even though we don't have that data point. Okay? So that's what linear interpolation does. The technique is actually pretty simple. Okay? So if we want to find the line between 2 points, we know how to do that, right? So what we're going to do is we're going to find the slope of that line. So our slope between, so for example, if we want the line between xi, yi, and xi plus 1, yi plus 1, right? So between 2 consecutive points, then we're going to find that that line is y equals the slope between these points, which is yi plus 1 minus yi, over xi plus 1 minus xi, right? That's the slope, times x minus x1 plus y1, or x minus xi plus yi. Okay? So that's the point slope form of the line, right? We take the slope and then the point that it's passing through. Okay? So this is pretty straightforward. You have to do this multiple times. You have to do this for every pair of points, right? And so going through and actually doing it can be a little tedious, but it's really just finding the equation of a line. Okay? And so if you started with the set of data points, so I'm going to do 3 points. So 0, 2, 1, 3, and 2, 5. Okay, so if you graph these, 0, 2, 1, 3, 2, 5, you'll see that they don't fall exactly on a straight line, right? But we're looking for this linear, piecewise linear curve. So first this piece, and then that piece, okay? And so on 0, 1, we want to use the line between 0, 2, and 1, 3. So that's a line with slope 3 minus 2 over 1 minus 0. So slope 1, so y equals 1 times x. The y-intercept is 2, so we could do 1 times x minus 2, or minus 0 plus 2. So we took the slope and then the point 0, 2 and plug that in. We get y equals x plus 2. And then similarly, we can find a line between 1, 3, and 2, 5. So on the interval 1, 2, maybe I should write these better. So for 0 less than x less than 1, for 1 less than x less than 2, the other piece, we're going to use the slope between these 2 points. So 5 minus 3 over 2 minus 1, so that's a slope of 2. Y equals 2x minus 1 plus 3, and so we get y equals 2x minus 2 plus 3, so plus 1. Okay? And so that gives us these 2 pieces. This is y equals x plus 2, and this is y equals 2x plus 1. And so this piecewise equation, specifically written out maybe a little bit better, y equals x plus 2 for 0 less than or equal to x less than or equal to 1, y equals 2x plus 1 for 1 less than x less than or equal to 2, and kind of 0 everywhere else. We don't want to do any kind of interpolating polynomial anywhere else. This gives us the linear interpolation between these points. And so if we wanted to say, okay, we know this data point, this data point, and this data point, what's the value going to be at y equals 1/2? We could say f of 1/2. We would use this piece, so we would guess that that's about 2.5. Okay, and so you can see halfway between 0 and 1 is 1/2, halfway between 2 and 3 is 2.5. So that's kind of exactly where we would expect it to be. Okay, so when you're using interpolation data, the important thing is not to go outside of the range. So interpolation literally means between points. Okay, so you can use this to predict values between 0, x equals 0, and x equals 2 to get predicted y values, but you can't use it outside of that range. And that's very important. Going outside of that range is called extrapolation. And while sometimes you can extrapolate if you've got a model that you've built, like the ones we built from regression, depending on whether the pattern continues, you can never extrapolate from something like this, right? So you can't predict that the pattern continues to go on in any meaningful way. Okay? So that's a linear interpolation, pretty basic. What we're going to talk about next in the next video is how you can find a polynomial that goes through all of the points, what's called the Lagrange polynomial. And we'll do that next.